This conference will now be recorded.
I did actually start in 1972. So after working for a long time with BR and including some fairly major projects such as Thameslink 2000, I got sold to Atkins. Having had a good time traveling the world with Atkins, I then moved to the Strategic Rail Authority. And when I was abolished by the Secretary of State for Transport for a second time, I decided to join him. And I then became the infrastructure technical manager in their small technical group, which gave me the opportunity to really engage with the industry through a lot of the committees and standards committees and system interface committees under RSSB. But one of the projects I did take on at that time was right from the very, very start was the Tram Train pilot. So there's on this one, there's only a couple of other people who've actually been involved with it as long as me. So on with the talk. No, I got to. Right. So what is a tram train? Is it a tram or is it a train? Or is it both? Or to some people, they seem to think it's a general panacea to local transport problems. But then to others, it's an abomination that should not be let near the real railway. I've heard it's all these options expressed by various people around the industry. But of course it is both. Its origins start in Karlsruhe. Karlsruhe, a city in Germany, which had a typical problem with local transport and road congestion. It's got a pretty good tram system, actually quite wide ranging around the city. And like Britain in those days, it had a rundown and failing commuter network. Not everything is wonderful in Deutsche Bahn, and some of their local commuter networks, quite often done with very old diesel stock, were not doing well. So they came up with the concept of what if they could run some of their trams onto the main lines as well. And that is where they came up with the tram train concept. They started it with a conversion, in actual fact, of the Autobahn in the Karlsruhe tram network, and they just connected the two together, electrified the Autobahn and run their trams all the way along that. And that showed a dramatic increase in passenger numbers, new train effect, electrification effect, and particularly additional services. So they use this to develop what is known as the Karlsruhe model of tram train. This helps where customers, we know they want to travel from their starting point to their point of destination quickly, cheaply and affordable. And this is where the Karlsruhe model comes in. Short journey times, well coordinated connections where they're required, comfortable vehicles, fares in line with the market, and detailed information. This is what people want. And the Karlsruhe model is able to fulfill all these requirements. You'll see the TTK symbol at the bottom right-hand corner. That's because I've stolen these slides from Transport Technique Karlsruhe, which is their technical authority, who actually are a consultancy as well. And they introduced me to all of this on a visit I had early on to Karlsruhe. And they helped develop it. So they started operating since 1961 by the conversion. And since then, they've converted quite a number of routes. And they put more stations in close to housing, because that's where people want them. They've been able to do it with this system. And they've enabled shorter journey times quite often because it's only one leg. And they've also developed the dual voltage, 750 volts for the city, and the German 15,000 volts AC system for when they're on the main line. So after the Autobahn, there's a bit of a gap before they did anything else, but in 1992, they did a pilot line with full interoperation, and that was going out to Breton. Now, if you look at the top plan there, you'll see the old diesel-run Deutsche Bahn route. Just about had a station in the major villages and towns, but not very many. And it was fairly slow, sluggish diesel trains. You'll see a point where the dotted line and the red line cross, and this is where the tram system, which is the dashed line, crosses the main line system. And you'll see in the bottom plan where they actually introduce the tram train, one, you'll see lots of blue dots, certainly to the right of it, where they put in new tram stops within the towns, villages, and to actually provide a stop close to where people lived. And by joining the tram system as they entered Karlsruhe, they were able to go straight to the commercial and shopping centre of Karlsruhe before going off and heading up to the Hauptbahnhof. So although the trams didn't necessarily go as fast as the trains could go, with the added acceleration, they could actually take you to where you wanted to go in the centre of Karlsruhe quicker than having to go all the way up to the Hauptbahnhof, the black dot in the middle of the city on the top plan, and then pick up a tram to take you to where you wanted to go. So what effect did this actually have on the operations? And you'll see on the right-hand graph an 8-fold increase in ridership. So that is really significant, and that shows what Tram Train can do. And there's some other quite impressive increases in ridership for some of the other lines they've introduced. So that's the origins of Tram Train. So where else in Europe has it been introduced? In Germany, where it started, so it started in Karlsruhe. I've seen it in Kassel, which followed on, and they've got a really good system they're putting together there. Nordhausen is slightly different in its a narrow gauge tramway, but it actually lines up with a narrow gauge railway going out of Nordhausen. Some of it with sort of heritage steam locomotives as well. And Saarbrücken, which shouldn't really be just in Germany, because it actually goes into France, first international tram train system. Also in Netherlands, they did a pilot on the Alphen aan den Rijn line. We'll look at that in a moment. And also they do it interoperating trams with metro trains on the Randstad rail. Spain introduced it in Alicante, and they're looking elsewhere. France, I've just put France because they've started introducing quite a lot of them recently, Mulhouse and other places. And where else? Well, the UK for one. And so let's have a look at Kassel. Kassel's an interesting one. It followed on from Karlsruhe, so it's learnt a lot from what happened in Karlsruhe, and TTK helped them with it, as you'd expect. But they also had a problem on one of their routes where they couldn't electrify it. So they actually looked at having a dual power one using 650 volts DC within the city, and then going on to diesel power. They put a diesel engine on the roof to give them the power when they're out on the main line and down the actual unelectrified route down to Wolfhagen, I think it was. So what does a tram train look like? What do their ones look like? This is typical for tram trains, and they tend to be sort of 3-car section units rather than the sort of multi section ones. That adds to the stability when running at speed on the main line, but it also gives the opportunity to have a central section where you could have it fully seated, and the end units seating over the bogie, but standing room and low floor entry elsewhere. If we look at Nordhausen, this is the one where I say it's actually works with the diesel units on a narrow gauge railway. They don't quite have full power for when they're on diesel because they don't need it. In Kassel, the diesel power gives them as much power as if they were connected to the overhead, but they need that to keep up with the trains on the main line. Here, the local services are relatively sluggish and slow themselves, so just a relatively small diesel engine within the unit is quite good. I'm told this is a very good system. A colleague of mine from the department actually has driven one of the tram trains out there, my rolling stock colleague there, so he assures me it's excellent there, and no reason to believe not. It's doing the job. Now, Saarbrücken is another interesting one. I've actually been out to Saarbrücken and been on these, and they have the international service. Saarbrücken is in Germany, but it goes right the way through and just across the border, which is very close to Saint-Germain, but it is in France. All trams are tram trains, and that means actually they have a special groove rail there, which is actually wider. But we'll come on to certain aspects of the wheel-well interface later on. But what used to confuse me was, well, France, that is either 1500 volts DC overhead or it's 25 kV like us. But of course, what I wasn't realizing at the time, because I wasn't that used to what goes on in Europe, is that sort of east of Metz, it's a German railway. It was built by the Germans, unlike the rest of French railways, which was built by the British. And they even swap which side of the tracks they run on. Most of France, they run on the left. East of Metz, they go over to the right. So if we carry on along, this is actually where the tram trains leave the tram system and start to move and join the main line. And it's gone through its changeover from the 750 volts to the 15 kV, and it's rising up to join the main line, which is on the left. And here we come to the border. And just to confirm, they actually point out that it is SNCF you're joining, but it is 15 kV. Another one I managed to visit while it was still running was the Alphen aan den Rijn on the Round High Line out of Gouda in the Netherlands. They wanted to do a pilot on Tram Train, and they managed to get one, and it on a relatively lightly used line. So it's done a fair bit of heavy rail, so it is fully interoperable. And they did it really well there. They wanted to ease passenger satisfaction and punctuality. They didn't actually connect into any tramway at that time. They were looking to do so, but they were just piloting it on the main line. They developed the safety case, and that led to no real problems for the main line. They did introduce a different safety system there. The detection problems they had for the vehicles was solved using axle counters. And what is really impressive was it only took them 14 months from the decision to go to get delivery of the first tram train. They got them from Stockholm, in actual fact, and that became the basis for the next steps. They actually finished the trial, and they actually reverted back to NS operation afterwards because NS gave them a good deal as well. So when the tram trains went back to Stockholm, it was very easy. We looked to see if we could buy them, but they weren't right for us. So what are the various types of tram train? there's the top one I put there, the full integration with mainline services, the Karlsruhe model. And this to me is the real tram train, but we'll go through the other options as well. But it's ideal if there's an existing main line with some spare capacity, or you can be taking over services, but the idea is to minimize the impact on capacity with the way you operate it. The vehicles are expensive. There's no argument about that compared with either a tram or just a simple light rail vehicle. But it can save the cost of installing a lot of new infrastructure. Then there's the taking it over, full segregation, what Karlsruhe did first with the Abteilbahn. And we've done that. It's just what we did in Manchester, in Croydon, Nottingham, Sheffield, and most of the original Midlands Metro. They just took over either old lines or replaced the services on lines as they did in Manchester. And that's fine if you've got a redundant line and you've got somewhere to actually bring the tram trains into the city centre. A cheaper vehicle option, because it's not actually a tram train, it's just a tram. Maybe a slightly stronger one because of the speeds you can get up to on the main line, but there's no compatibility issues to work with. And there's another one, which is, I think it's got a couple of places where it's used, and that is actually where you just segregate by time of day. So on the actual track, there's either only tram trains or they're mainline trains. So you have to prove the route is clear of any tram trains before, say, a freight train is allowed onto the route, and vice versa. Often used where mainline traffic is mainline traffic is light and can be limited to night times only. So ideal for freight routes, not so good on mainline passenger routes. So why were we in the UK interested in tram trains? Some people thought of it as a solution looking for a problem. I always apologise to John Parry here for his showing a picture of his Parry People Mover. He found a place where it worked beautifully, but he hasn't been able to find many other places yet, although they are looking again. Is it a solution for a problem we didn't know we had? Who knew we really must have our smartphones on and with us all the time these days? Or is there a problem that it may solve? And this is actually where we concentrated. And initially, we looked at matters of urban connectivity and city centre station congestion. Could we take a service out of the city centre and put it into out of the city centre station and put it into the city centre roads? And when we did look at rural branch lines, can we have an off-the-shelf vehicle that would do them as well? But we soon realised that probably wasn't the best option because tram trains aren't cheap, and you can get a light rail vehicle a lot cheaper. And keep your eye open and see what's coming out of the Warwick Manufacturing Group at Warwick University with the Revolution vehicle, which is what that one's really designed for, all being funded by the Future Rail Innovation Grants. So, problems and opportunities. Where can it help? Some mainline city centre stations are really congested. Some more so than they think, some less so than they think, in actual fact, from a study I had done when I was at the department. And there are some underuse suburban lines that could be made much better if they actually connected into a city tramway. And we mustn't forget that we've been saying goodbye to the Pacers. We should have actually said goodbye to all of them by now, but there are still a few around with being allowed to run, but it won't be for much longer. They ran out of their approvals, really, other than for concessions at the beginning of this year. So, how do you find out if tram train is the answer? First of all, go and have a look. I was sent out in 2006 onto a study tour being organised by ACORP, as the Association of Community Rail Partnerships, and we went to look at Karlsruhe and Kassel. But I was sent out there by the Director General of Railways, Dr. Mike Mitchell, with a view for making a recommendation where he could go and have a look. And I think in many ways, because of the way that Kassel had and was still building everything, but also they did have the diesel option, I thought it was best to go to Kassel. And I then was given the job of arranging a tour for some various senior people in the both the department. Network Rail had someone called Coucher wanted to come along, and Professor McNaughton. And then later on, I was told that the chief executive of Nedrail, Anton Volt, was going to join it. No pressure on organising that trip. Anyway, we went and had a look at it, and they were extremely impressed. And on the train back from Kassel to Frankfurt Airport, they were all trying to work out how they could borrow a tram train from Kassel and bring it over within 3 or 4 months and get it going. So the project team was established initially with the DFT as sort of sponsor role, Network Rail and Northern Rail looking at the operational sides and the where it could go. And we were given a budget of 25 million. Yeah. So like all good projects, we developed some objectives. And these are the 4 main ones. I'll go through them in a moment. They were as objectives as, you know, we have an objective on cost, an objective on timescale, and like things what we're seeing with the Brexit things, timescales go out the window, costs go out the window, but these 4 objectives have actually stayed the whole way through. What they're about, the first one's about cost differences. Money is always important. Where there can there be savings? Where are there extra costs? Where do you need to look at to control costs? Next one is standards. We all know you can't put a tram on the main line for standards reasons. It's not strong enough and everything. So we have to look at how to change the standards, maintain safety at the current level, and then they get it agreed at the standards committees. And we did all of that. There's no point doing any of this if the passengers don't like it. And we'll come to that at the end of the talk, what they really thought about it. But that's one of the things we were looking at. And finally, we wanted to look at how you operate between the 2 different systems. Bearing in mind that street tramways are relatively loosely operated, so they've got to run in amongst vehicles on the street and then come out and then go and join a highly well timetabled, highly regulated railway, working to signals rather than line of sight. But that's just the operational side of it. There was a technical side of it. Timetabling is always an issue, and you've also got to sort out the legalities between operating between the 2 systems, and that kept quite a number of people quite well occupied over the years. So in spring 2007, the team was established. We did our initial route selection that year, working against those 4 main objectives as to help us decide which one should be chosen. And initially we chose the Penistone line. It was really good for 3 of the 4 objectives. Certainly could look at costs, solo running. There's quite a bit of length of dual running, some with up to 100 mile an hour stock, some with more freight on it. But it didn't have the link into an existing tram system. So we always had a second phase of linking into the Sheffield Supertram system. However, that was going to rely on having a diesel electric tram, much as they had in Kassel. And when we looked at that, we found that the standards in Europe had changed. for good reason as well, because they were the emission standards. And we had to then comply with the non-road mobile machinery regulations phase 2B. I think it's moved on to phase 3 or 4 now, but that meant that the existing power packs that had been designed were no longer legal to be put onto a new vehicle. And the cost of developing a new one, which would be compliant, was going to be too much. It was going to use up our whole budget before we'd actually got a vehicle. The only way that the manufacturer would absorb the cost was if we're going to buy 25 vehicles. And we were only looking at 4 or 5, so that wasn't going to work. So we terminated phase 1 and logged all the learning we'd done, because we'd done quite a lot of work on that. So we actually logged it as learning and then start moving on to phase 2. And it was initiated, and at that point we brought in South Yorkshire PTE and South Yorkshire Super Tram Limited to join the team. We still kept on Northern to give us the main line experience and the main line input into the project. And they actually did the initial purchasing arrangements for the new vehicles. So we had the project running, and you can see the route it was taking was from Cathedral tram stop in the centre of Sheffield, going out as far as Meadowhall South or Tinsley, and at that stop it would then divert and then join initially the freight line and then a passenger line going through Rotherham Central up to a place called Parkgate, which is where there's a retail park. So why so long? You can see it took, it's taken years and years and years. They do it in Germany. What's the problem? Just get on and do it. And the number of times people, when I was at departments, came up with their brilliant ideas and put their just get on and do it. And I'd look at the brilliant idea and think this is a load of crap. That's Charlie Romeo Alpha Papa, if you don't understand what that means. No, you've got to look at things properly, and we know that in the real railway. And German track designs are different. They've got a different rail inclination, so we're going to have to design a new rail profile, which would work both with the 1 in 20 that we have, plus the 1 in 40 which tramways tend to use, because they tend to follow a lot of European practice. And of course, when you're in a street, the rail is vertical. And we've also got a problem with the flange width. And that means that we were going to need raised check rails, which are just the norm in Germany. So not for us and not for the French either, actually. And again, we design their railways. And also signalling is different. Germany uses a speed signalling system, and they have widely available their Induci ATP system. And that's the yellow block on the side there. We don't have ATP on many lines in this country, and where we do have it, we weren't looking to put tram trains, but we do have TPWS on critical signals. Would that be good enough? Because the Germans required for a tram train to run on the mainline railways, the line speed must be no more than 160 kilometers an hour, and it must have an ATP system working on it. So we could always fulfill the line speed requirements, but we hadn't got the ATP. So we had to look at that very carefully. So what makes a tram train? Well, a tram train is a tram that has been adapted to run on the main line. It's not a train adapted to run on a tramway. It's very much the former way around. So it's got to be fitted to be road legal. Headlights, rear view mirrors, or CCTV direction indicators. It needs to have the transponders on it to actify the tramway switch and crossing network, because it happens automatically. The tram has its VIS loop or vehicle identification system, so it just tells the points which way to go if the controller doesn't need to do it for other reasons. It needs a tramway comm system. It's a legal requirement in this country and most places that trams have magnetic track brakes. That's an electromagnet hung between the wheels on a bogie, and it just grabs the top of the rail and it then stops the tram very quickly. So that's the emergency track brake. When they operate it, and they tend to the Karlsruhe people said drivers operate it tend to be once a day or so. But when you do operate it, if you do it from speed, you get very friendly as a driver with quite a few of the passengers. So you don't want to do it unless you really need to. And you've got to have the right power systems, normally 750 volts DC down to about 600 or 550 in places like Blackpool. But it's also got to be able to run on the main line. So that means you've got to have rail headlights on it for a start. You have to be brighter. You need 3 of them. You've got to be interfaced with our AWS and TPWS systems. And in the future, ERTMS. You've got to have the GSMR radio system, because that's got all the emergency stuff on it, as well as the contact with the control room. And you've got to have some form of traction, which could be diesel, could be 25 kV, could be battery, could be, people keep talking about hydrogen, but I don't see that myself in the near future. Supercapacitors, perhaps. So that's what the vehicle's like. And what's about the service? Because we should always think of the service as well. To be a tram train, it's got to run on the tram as a tram on the city streets. It's also got to use the main line for part of its route, interoperate with other mainline trains. So if it doesn't interoperate, it's just an express tram, as they've got in Manchester. If it doesn't run on the street, it can just be another form of light rail, like they've got in Newcastle or London Docklands. So a tram train is a service. It's one that operates both on a city tramway and interoperating with mainline trains on the main line. So the vehicle itself, you can't just put an ordinary tram onto the main line. It hasn't got the crashworthiness. So you've got to look at how you protect it. You've got to make sure you've got the train detection and protection working. You might be introducing a DC system onto an AC or a non-electrified railway. So you've got to look at the signalling system. The wheel profile, I'm going to come to that in much more detail later on, but that is really important because you've got to get that right. So we talk about vehicle headlighting. Then you've got to look at the infrastructure compatibility, platform heights, any other track issues, and the electrification. And for sort of mainline railway people, after they realised it was the law at the time, God knows how much longer it may be, but you have to comply with the technical specifications for interoperability. Now, the vehicle lock and pass TSI actually exempted tram train vehicles. And we in the UK, the Department for Transport, who acts as the member state, it exempted 750 volts DC because that's not covered by the energy TSI. And also, for operational reasons, we wanted to get some tram type equipment like the vehicle identification system loops onto the main line. And there's no way they can comply with any TSI because they're not appropriate. So we made the appropriate changes that was needed to allow these things to happen legally. But with all projects of complexity, and this is a complex project, the devil is always in the detail. And I've listed out quite a few, by no means all, of the issues that needed to be addressed. But I think I'm going to just pull out 2 there. Tramway mindset and heavy rail mindset. They're very different. Tramways are very much get up and go, can we do it? if you can see it's safe to drive, you can drive it. They don't have signalling systems. They have a lot to comply with in terms of road requirements, but they tend to be much more agile than we seem to be on the main line. Whereas the main line is very cautious, risk averse, and looking very carefully at what it does. And if someone wants to come and do something different there, you have a lot of, you have to explain why to everybody. And you have to sell the concept to a lot of the people who are taking the responsibility on the main line. And that is where a lot of the people who are pushing for these things today don't understand that there are people in the line, on the main line, and that's the management line on the main line, who actually have to take responsibility for the operation and any changes you make to their systems. So we did get there in the end, and we addressed all these matters and more. So what infrastructure works were there? Well, the provision of low-level platforms. Only one station we had to do anything particular at, and then just put in a tram stop, was Rotherham Central. Now, the Sheffield tram system, that has a platform height of about 350 millimetres. So with a floor height of 360 millimetres on the trams, no way can you just climb up and get out on a 915 platform. So we did have to put an extra platform in, and this time at the southern end of the platform with a ramp between them. And you can see a nearly finished platform there just before we came into operation. And there's the ramp between the two, nicely guarded and parallel, so you don't unlikely to run off into the line. And this is a typical one I took in Randstad Rail, where I think the ramp was a lot steeper than we would allow, but they had metre-high platforms for their metro and 3 80-high platforms for their tram trains. And you notice there a black fence between the two, because this was to discourage anybody from trying to think they can cross the from one platform to the other just across the tracks. Okay, and it often happens in a tramway. If you want to get across the track to the other platform, you just cross the tracks. That's the way you do it in a tramway, but you can't do it in a mainline situation. And we had to look at that, and we did actually put up a form of fencing as well. You've got to make things accessible. We have to have accessibility these days in particular, but trams, you do have the ultimate accessibility in a very narrow gap between the tram and the platform. So you can self-board if you're in a wheelchair. We also had structure gauge clearances. You may think a tram is smaller than the train. Well, it isn't actually. It's a lot boxier, especially at the top. But it's also we had to put the electrification in as well, which also made a difference. And then signalling modifications. Protect a tram train, you've got to stop other trains hitting it, basically, because it is a lot weaker and it hasn't got the buffing points quite so well defined. The centre of strength in a tram train is a lot lower than it is on a normal train. So we had to protect it. And the way we did it, we followed very similar to the Sunderland extension of the Tyne and Wear Metro, in that we put TPWS on every signal instead of just the critical ones. And that effectively provided us with extra protection against a train following on, particularly a freight train, spadding the signal and then hitting a tram train, which would not be healthy for anybody on the tram train. So there's a picture I took of what they'd done on Tyne and Wear Metro. And you actually see an inducee loop beyond it, because that's what Tyne and Wear Metro use as their system. They just dual fitted the railway there, so that every vehicle from Tyne and Wear could go on the Sunderland extension. Right, other projects always get in the way on our railways. And the first big hit we had was the recontrol of signalling to York Regional Operations Centre. And we were suddenly told we hadn't got any signalling staff available to do the changes that we needed to enable us to put in the junction to connect the two railways. We hit the roof as a project. The minister hit the roof as well, and suddenly Network Rail changed their tune. Yes, they could find the signal engineers to do the change, but however, it didn't make any difference to the loss of time that they had promised us, because they had other things in the way as well. So that put things back. And then there's electrification. We chose to electrify this railway because batteries weren't really there now. I think if we'd done it now, we would just have made it a battery one, much as they've got in Birmingham for the extension up to Centenary Square of the Birmingham tram system, or the Midlands Metro as they call it. So we were electrifying it, and we looked at 25 kV or carrying on the 750 volts DC. And the 750 volts DC made sense initially, and I even got them to accept they could put tramway type electrification on it, until the minister, Andrew Adonis, said, no, we're going to electrify up to Sheffield on the Midland Main Line. This was before the great price increase, etc., the problems on the Great Western, which has now delayed the Midland Main Line electrification, put it right into touch. So we were looking at that, and the thought of then having to take down some cheap tramway type electrification and put up some heavy rail electrification was too much for Network Rail. So they decided they were just going to put in their Series 2. What they didn't realise was how much they were going to have to change on that to make it fit for DC, and they weren't too up on DC design as well. So that caused them some problems in the alteration of the system, because there are significant differences of what you've got to do. But they did adapt Series 2 electrification for 750 volts DC. They know how to do it now. But this had an impact on several bridges. If we'd gone for 25 kV, we'd have had to have rebuilt 3 bridges, because we wouldn't be able to lower enough to do it. But there was still one bridge which was a problem at Rotherham Central, and you can see this pacer only just getting underneath College Road Bridge, the red and white one, metal one at the distance. We couldn't make enough clearance, even with 750 volts DC electrification, without either lowering the track, and lowering the track would have been a mega problem with the platforms so close, and altering those platforms would have also been a significant issue. So they decided to rebuild the bridge. I said that was going to be a problem, because I looked at the layout of the bridge, but the Network Rail engineers, without looking at the site, said, oh no, it's an easy thing, we can rebuild bridges. Yes, I know you can rebuild bridges, but you've got to look at the road layout as well, which they didn't do. So they ended up just raising it enough for 750 volts. If they want to bring 25 kV through there, they've got to do the major roadworks to lift it up the extra amount. Or it's not somewhere where you can put in a dead section, particularly because you're too close to the platform. But they did that, and they now run through. Track issues. Well, I said I was going to come and talk about the track. I said rail inclination, main line 1 in 20, tramways 1 in 40, and in the roadway vertical. So you got pretty even split between the 3 inclinations there. So you've got to have a wheel profile that's going to work with all of them and not cause excessive wear on any of them, which is what the tramway really feared, that they might get excessive wear. So what are the differences between a main line and a tramway wheel profile? Well, I've got up here 4 tramway profiles and 1 main line. The top one is the good old favourite BRP8, the one we know and love, and works very well. Next one down is the Croydon one, which is similar in places, but not too bad. Then we've got Sheffield Supertram, which is the interesting one to look at, particular. A fairly low flange height and a flat top, because it does do some flange tip running in places. Then we've got the Castle one, which has got a very deep flange, but still with a slightly flattened top as well. And finally, the original Manchester Metrolink one, which is a slightly adjusted P8 profile. But the thing to look at in both of those, at the top of this plan now, is that the Castle one and the Manchester Metrolink one all get wider above the rail level. And that is so they can interact with raised check rails, particularly at points. So they do get the guidance through. If they didn't do that, with the flange being 10 mil narrower to work with the city street grooved rails, you would just get the flange potentially hitting the nose, which will do the wheel no good, do the ride no good, and do the nose no good. So you've got to do something there, and that's particularly a problem on the turnout road, and there'll be a few of those around. So that is why we've had to introduce raised check rails on the main line. The other issue was established by Huddersfield University, their Rail Technical Centre. They looked at the ride over the network rail type switch tips with a shallow flange, and they reckon that there was actually a good chance that it would rise up the switch tips. There was a good risk of that, so we had to have a deeper flange. So that meant problems with the city centre rails. Oh, there's a few things in raised check rail. Right, the city centre rails were very worn. As you can see from this picture of a rail which had been taken out of the city centre in Sheffield, the wearing surface on the rail is well below the level of the keeper, where it should be up. It's also quite well side-worn, that one. You can see from the rust strip of where the wheel had worn the rail down. And the trams there were basically a mixture of flange tip running and wheel tread running. So they needed changing anyway. And they are actually going through a process of changing all their street running rails to a new rail. But we need it particularly to get our new wheel profile in to go all the way to the cathedral stop. And this is the rail they replaced it with a much deeper flange way. Schedule took forever, didn't it? Well, we really started going on the phase 2 start in 2013, where we started to negotiate supply of the vehicle and refine the infrastructure costs. Then late 2013, we got the minister's go-ahead, a very brave decision, minister, and a funding agreement was made with the SYPTE. Network Rail involved their contractor, early contractor involvement, late 2013, and lo and behold, the cost went up. So when the costs go up, you review the infrastructure, and there was one particular point we looked at, and that was around the junction between the two. We were originally going to have the junction at the bottom of this plan, where the two actually merge or get very close together, and have a separate platforms on the diverging route. But we realised we could actually save quite a bit of money if we actually just move the junction down, only one pair of platforms, clearer for the passenger to use, and then go over some former railway land, which is now goes underneath a motorway and an A road. Now this land was no longer railway land. It was actually under the stewardship of the Highways Agency, as it was then. Therefore, it was actually owned by the Secretary of State for Transport, which is useful because it was an internal transfer from Highways Agency to Network Rail we could arrange for the land that we needed. So we revised the layout, got a TWA order done very quickly, because they wanted to make sure that this bit of track was actually designated tramway, so we could put a level crossing on it for access reasons for the Highways Agency. We got it all going, and start of service was on the 25th of October 2018. Not quite 14 months, I'm afraid. So, and this is the rolling stock we bought, which is initially a Voslo vehicle, but Voslo, their tram side, got bought out by Stadler, so it ended up being a Stadler CityLink vehicle, and it's got all the things you'd expect on a tram train, with the same passenger capacity as a Pacer as it could effectively replace. And for those who are interested in the technicalities behind it, there's this slide here. So you've still got to get approvals for any vehicle and any infrastructure. So how do the approvals work? One Tramways is the old system of ROGs and safety verification by an independent competent person, all well known by the tramway industry ever since the death of ROTS. On the railway, of course, it's very different. It comes under the Railway Interoperability Regulations 2011 as amended, and then you need to check compliance with TSIs and use a NOBO for that. You need to have compliance against the notified national technical rules, which are the bits to cover compatibility with existing infrastructure and where there are gaps or silent points within the TSIs. And then you have a designated body, a DBO, to check compliance with that. And then you have to do your safety assessment using the common safety method, for which you need an assessment body, an ASBO. Now, of course, all these different people or different bodies can be the same person or same organisation. But we've got to do 2 lots of approvals because we need both of them. But the use of CSM for risk assessment for both routes removes some duplication, and we use common methodologies where we could to minimise the problems and get the approvals as quickly as possible. So what have we learnt? A lot. Got to be a lot for all the time we put into it. And the learning is being stored in a Sharp Cloud website. It'll be available to view soon on request. And it's being managed by Network Rail, and I've already got access to it, but other people will be allowed access as and when. So what have we got? We've got a service start on the 25th of October, and it starts at Sheffield Cathedral stop. And this is where it actually joins the main line. So this is what all that work was really about, enabling a vehicle to do this move. So it is now on the freight line from Tinsley Yard through to Rotherham. Rotherham low-level station or platforms. You can see the barrier now to discourage people from running across. And this is just a service tram train arriving in the platform. And at the end of the day, it's arrived at a terminal stop with a fence against the main line on a little spur at Rotherham Park Gate, where you can access the retail park, and a sort of park and ride is almost effectively there with the large amount of parking they've got. And initially we got 100% customer satisfaction. They really loved it, the passengers loved it, and I could tell that from one time when I went to a light rail excellence day at Rotherham, and when we came back to the station to head off home, a tram train came in and just loads of people piled off it. That was really good to see, and that was mid-afternoon. It wasn't even peak time. So where else next in Great Britain? Manchester Metrolink are looking at the Marpole and other lines. Birmingham is looking to Wednesbury to Brierley Hill and potentially on to Stourbridge Junction. And as you know, down your part of the world, Cardiff Metro looking Queen Street to Cardiff Bay and potentially elsewhere and up and down the line. So you've got tram trains on order now, high floor ones, to take you into Cardiff Bay. But I thought of another option when I went down there. I went down there with Alan Wilkins, who's on this call, to have a look at it. And I thought putting a tram mindset into place rather than a heavy rail one, I looked at the area. What are they replacing? They're replacing the Cardiff Bay branch, which you can see on the left-hand side, and they want to access all the entertainment venues really in Cardiff Bay, as well as the residential accommodation and everything else around there. But just walking up and down the area, I was actually quite shocked. Down one side in Bute Street, you've got, let's say, an area which could benefit from some regeneration. I won't say gentrification, but regeneration. It was looking a bit sad in places, but it had this big grey wall on one side of Bute Street all the way down, and that was a hell of a barrier. And just above that, you've got the Bay branch, and this is the other end of it. You can see where the Bay station is. That sort of dirty grey building on the right-hand side is the old station, now derelict, waiting to be regenerated itself, and just a single-ended platform, single-track platform just beyond it on the old line. But if you go to the other side of the railway, to Lloyd George Avenue, you've got a dual carriageway, hardly used. And if you look down Lloyd George Avenue, you can't actually see that there's a station there, except when a train might just about appear above the hedgerows there. It is virtually invisible, and in the bottom picture you can just about see where there is one. Thank you, Google Street View, for these pictures. And I thought we could be better off making trams do what they do best, which is make themselves visible. And we could possibly get some social cohesion into the area and actually start to put the incentive to start some regeneration in these fairly rundown Bute Street area. So Lloyd George Avenue is not exactly heavily used from what I could see and from what I've been told. So you could take up one of the carriageways and put tramway in that, possibly bus as well. So make that a public transport corridor and put the cars in the other one. You've then got a visible tram. You've got visible rails in the street, and you know that's going to come a lot. And visibility is really what makes trams work. They found that in Birmingham when they brought it into the city centre. Suddenly ridership really boomed. And then that leaves you where the old Bay branch used to be, and quite a wide corridor between that and Lloyd George Avenue. Ideal for some development. Knock down the wall, do some levelling across between the two, so you haven't actually got that solid barrier. You can then start possibly put a bit of development in that area to help pay for all the extra costs. That was my idea for the Cardiff Bay area. And then you got potential for extra stops and also potentially a link into the Cardiff Central Station and potentially into the city as well. I've now got a video by Network Rail, by the people who actually did it. So it's not just Network Rail. So
hold tight, please.
It's a completely different style of driving on Network Rail as opposed to driving on a tram system.
Compared to the tramway, I'm used to seeing pedestrians, cars, traffic lights.
One of the most difficult aspects to come to terms with has been the transition between line of sight driving and driving to signal.
We've had to learn a new rule book and get used to new safety systems such as TPWS, AWS.
It's been exciting working on the pilot scheme, and it's been well done.
This is the tram train service to Parkgate. The next stop will be Rotherham Central.
In 2009, we set out to bring Tram Train to the UK for the first time. In 2018, we had delivered that. We have a service running from an on-street tramway seamlessly onto the national rail network. And in doing so, we have learned so much we can share with the rest of the industry. Network Rail sponsor, a key challenge for me is to create, develop and retain the key collaborative relationships that have made this project a successful delivery, particularly those with South Yorkshire PT, the Stagecoach Supertram. We're already very happily engaging with a number of stakeholders across the country, in Glasgow, in Manchester, Cardiff, and Bristol, to name only a few, who are keen to understand the opportunity and benefits that tram train technology could hold for their own city regions. We're also creating a virtual database of information about all aspects of the project, which we intend to launch within the next 2 years on the Sharp Cloud website, which will be available to anyone who wants to learn more about what we've been doing and hopefully apply it in their own situation.
It's been a real challenge to coordinate all the different contractors on the Sheffield Tram Train project. We had over 20 different contracts let, internal and external, and then in April of 2018 we lost Brilliant. That really put a dent in the project and a real threat to the success of the overall project. Luckily, having a great project team behind us, we managed to get ahead of steam, bring in a new principal contractor and deliver the project on time. This was a first for me, delivering the project with a number of different external stakeholders, working with the Sheffield Passenger Transport Executive and working with Sheffield Supertram has been a real eye-opener for me. The help that we've had from them has been fundamental to the real success of the project, and we couldn't have done it without their ongoing support. The key learning points for me for any future project looking at doing a tram train interface project is to make sure you get your requirements right from the very offset. Ensure there's a just business case and try, where possible, to make the alterations to the tram or to the rail system as minimal as possible.
The new infrastructure that the project is installed on the area of the tram train, we've introduced a new cord at Tinsley that joins the Supertram and Network Rail infrastructure together. We've introduced a 750 volt DC overhead line system, and as part of that, we've introduced a DC traction substation that you can see behind me and a track sectioning location at Tinsley. In regards to signalling changes, we've introduced access counters along the route and vehicle identification system loops to identify the tracks. We've changed the signal panel at Woodburn, and we've also introduced low-level platforms at Rotherham Station and a new transport compartment. Some of the key engineering challenges on the tram train project was achieving electrical clearance for the new vehicle in the OLE. This included 2 track lowers and a bridge loop at College Road. The Series 2 OLE equipment has double insulation, so there was product approval for that, and gauge clearance of the vehicle across the route. Earthen bonding for DC. This is a non-electrified route, so there was a lot of design went into the earthen bonding and interface management on the boundary for electrical control.
Most of the key operational challenges in the Tram Train project have fallen at the system interface between the 2 network operators, namely Network Rail and Supertram. You have 2 very different organisations with very different technical standards and working practices, and the key has been to align these to ensure safe, robust and practical operation on a long-term basis. The project has also required the development of operational and maintenance boundaries across the Tinsley core. This has required a significant amount of work with our operations and maintenance stakeholders in both organisations to ensure robust methodologies for proactive management of operational and maintenance practices and databases. Part of the project required the creation of a new method of operation, namely line of sight infrastructure, to allow loaded passenger trains to operate over unsignalled routes. This in turn has required the development of a new operational methodology for the protection of staff, which involves possession of line of sight infrastructure in the absence of
In terms of testing and commissioning of the city vehicles,
was quite challenging. We had 7 new vehicles, 4 will operate as tram trains, 3 will operate as trams. So that leads us to having a mixed fleet, which we've never had before. Very challenging in terms of driver training, competency, and then of course we have to comply with highway standards. The original Supertram rulebook was taken from Railtrack. We had that in place from 1993. It was revised over the intervening period. And then in 2017, we've been looking at railway standards to support the tram train operation and how we would use them to operate. The biggest challenge for us has been communications. We do train to the safety critical comms protocol, but we're coming up against new terminology now on network rail, and our drivers having to work on 2 sets of rules.
There have been a number of challenges in managing the extension into the network first time in 25 years, including alterations to the tramway and the depot that you see behind me, whilst keeping the existing Supertram services running and fully operational. Also, we've procured a new fleet of CityLink vehicles, which again for the first time for a while, which has been a challenge and really good lessons learned. And of course, now we've got a new interface with Network Rail to manage. A key focus of the Sheffield City Region Transport strategy is to improve connectivity and provide improved access to jobs and trade. And we believe that the Tram Train really fits that bill. It allows people greater flexibility to jump on the tram on the existing tram network and then get off in the centre of Rotherham and Parkgate. We also envisage that the Tram Train will bring some real economic benefit to the corridor between Sheffield and Rotherham. We want the Tram Train to be able to reach its full potential. So already we're looking at additional stops on the route to Magdalen and potentially a new park and ride site at Parkgate. Furthermore, we're going to be working with our colleagues in the Sheffield City region to see how we can expand the Tram Train concept and also the existing tramway. And we're really proud that South Yorkshire are leading the way in this field.
This is Parkgate, where this service terminates.
I hope that gave you an insight to the operations and what the people who are working on it really think about it, a bit more than I could give. Now, we've on it. We've actually got them operating. So they put the project forward for Light Rail Awards last year, and they put in 2 categories. Firstly, major project over 50 million euros, and they became highly commended. That's the runner-up, effectively, in their terms. And then the other one was Team of the Year, and that was when they looked at all the different aspects and interfaces they had to manage for this project. We were the winners, and I was even dragged up to that time to stand up on the stage there, along with a good number of people from Network Rail, South Yorkshire Supertram, SYPTE, and the department. The person at the right in the front being the last sponsor for it. So that is my presentation. Any questions?
Right, we've had a couple of questions come in. So the first one is from Andy Batters, who says, in terms of standards, can the model used on Tyne and Wear, where they have 2 signalling sections clear, be adopted wider? And a related question, is this practical with the existing network utilisation and infrastructure capabilities?
Right, yes, we looked at what they were doing on Tyne and Wear Metro, and the 2 signalling sections clear was a problem for us because we wanted to be able to introduce tram trains without impacting on capacity. So we developed it and did more safety and risk assessment work, so we don't actually have the 2 signalling sections clear. We just run it as normal, but we did put the TPWS on every signal to ensure that we've got some means of controlling errant trains behind.
Okay.
Yeah, I think that covers it. Yes, it covers the practice, because we didn't think it was practical, thus we did the extra work.
Right. So the next question comes from Carl Gilmore, who's with Transport for Wales. So on existing infrastructure where it was upgraded from train to tram train, I'd be interested to know what time allowances for dwell times were made and whether there was a cultural change. So that is, people getting quicker on and off once commuters got used to a new fleet.
Right. Right, it's an interesting one, Transport for Wales, because I understand you'll be taking over quite a few of the lines from Network Rail. I think it was a move really to more of the tram culture. I think you can do more than we could do on this one, because we were working, when we were running on the mainline railway, we weren't running to signals, running as a train. Now, tram trains, by the number of doors and passengers, means we can actually get quite low dwell times. They're used to low dwell times there, but the processes are still the same. You've got to be able to make sure your doors are shut before you can start off. So it's more of a vehicle matter, I think, for dwell times. And the drivers we got were all tram drivers trained to go on the main line, not train drivers trained to run on the street. That's what they did in Castle. They trained half of their train drivers who were going to operate the service from mainline drivers and half of them from tram drivers. And the tram drivers worked on the main line relatively easily. They could do the switch to working to signals. However, the train drivers found it horrendous in their respect to go onto a street and have to be looking out for people and vehicles, which they weren't used to. So I think if you are not running as Tram Train, if you're actually running as a converted railway, you can actually then start adopting more Tram Train type procedures. If you're running as Tram Train, you will be working in a heavy rail environment because you'll be still working to signals.
All right. Okay, excellent. Right, Alan Wilkins comes in with a bit of news, really, I think. So Cardiff City Council last week announced plans for redeveloping most of the area around the last 400 metres of the Bay branch. And these proposals would incorporate many of that's Tim's ideas, plus get rid of the terminal station proposed by Keolis so that tram trains can continue via Pengham to the proposed new Cardiff Parkway station at St Mellons. The terminus platform proposed by Keolis was the worst aspect of their proposals for the Cardiff fellas, as it would have prevented connected east-west running along Clarence Road.
Oh,
Right.
That's really good to hear.
Right. Right, so Gilles Moulec apologises he had to go off early and says, thank you very much. Very interesting talk. Okay. So, another question, is the usual arrangement of integration of service when a station serves both mainline heavy rail and tram train? Would passengers be required to tap out from the National Rail Network and tap in again for the train service?
Oh, an interesting one. Yes, well, on the Sheffield route, the tram was running under tram tickets and the mainline railway was mainline tickets. As Sheffield trams work with conductors and no other means of revenue protection or ticket purchase as well, there's a few opportunities at some locations to buy tickets, but they have to be exchanged for tickets on on the tram, it was very much separate ticketing, and up there they hadn't got any 2 active smart cards, but I think if there was going to be smart cards used on the mainline railway, yes, there would be a tapping in point at that point. Now, when you get to any revisions to the ticketing or common ticketing, such as they've got in London, say, where you can use your Oyster card on the main line and on the buses and underground, you don't have to sort of tap as you go between the two then. So it's really up to coordination between operators and potentially the local transport authority if it's got some control on the main line to encourage it. But it's certainly something which we would look to see to get is some integrated ticketing. I'm a great believer in that. And when I had to attend a select committee style inquiry operated by the all-party parliamentary light rail group on that, that was one of the questions I was given as a official. I couldn't give a firm answer because we didn't know at that point, but certainly I'd like to see unified ticketing around certainly local areas. I've benefited from so many times when travelling around Europe. Oh, well, I'm not allowed to say that, am I? That we could certainly do with a lot more integration within our transport systems in this country, your country of Wales and Scotland as well.
Okay, thank you, Tib. I've got one question myself, or really a comment. Certainly, you mentioned that you'd had some modelling done looking at the issue of using a shallow flange, wheel flange for flange tip running. And the problem with the interface for the switch with normal heavy rail switches. And I can certainly vouch for the fact that both on Midland Metro and on Nottingham Tram, we actually had derailments that were caused by exactly that problem. The tendency is the sharp corner, as it were, on the bottom edge of the switch digs into the face of the not a normal 1-in-4 machine switch on a heavy rail switch, and it does indeed lead to problems with derailments. So that was definitely the right call.
Right, that's right. Good to hear. Because
right. So, yeah, another couple of questions come in. So, so first of all, the previous question said, "Thank you for your previous answer. Would onboard ticketing be encouraged?" Yeah.
Well, there seems to be a variety in the tram world on that. Somewhere like Nottingham, you have to have a ticket before you join, whereas Midland Metro, Sheffield, well, Blackpool, you can buy tickets on the tram and they have conductors there. It's all a matter of really what works best in your locality. In Croydon, where you're in the Oyster area, everything is Oyster. You've got to have tapped your Oyster card before you join the tram. Otherwise, you get a big fine if the inspector catches you without a validated Oyster. So it does vary around the tram world what is permitted. And the trouble is, if you've got to have a conductor on the tram, you've then got to have the staffing for that. And also at peak times, it can be difficult for the conductor to actually get through everybody. I know I benefited once going to the depot in Sheffield from Sheffield Midland Station, and I managed to get there without paying. Not that I didn't want to pay because I wanted to pay me back, but it was a case of I didn't have the opportunity to pay. So there are pluses and minuses for both, but certainly in places like Sheffield, I think Blackpool, they do really like working in cash and just jumping on a tram and paying cash there and then, rather than having the fag of buying a ticket first and potentially missing a tram while they get it.
Okay, right. Andrew Wilson asks, given that the Sheffield system was the UK first, would subsequent schemes offer economies over tram or heavy rail, and where would these be?
Right. One of the points of the pilot was to actually understand the cost side of it. And we were therefore funded to make the mistakes as such, and everybody's got an opinion of all the mistakes we made. They didn't understand the process we were going through, but we now understand where the costs are, so we can save all of that. We've got the Sharp Cloud website now available, so anybody can find out what we did and why we did it, and then make their own decisions from that. Plus, Network Rail have got a dedicated light rail team who actually know all of this because they were the people involved. So Simon Coulthard, Alex Dodds, you saw there, Ian Ambrose, are all people who know inside out of what went well, what went wrong, and have put together the actual Sharp Cloud website, which has got a lot of information in it. Last time I looked, there's still quite a lot missing, but it's one of the few projects I've been involved in that has had the review during the project run to actually work out a lot of the problems and actually record the ways they got around it and the learning, and have also made it available. I've been on other projects where they've had a lessons learnt workshop at the end, and it's gone into a short document which has gone onto a shelf or somewhere into a server, never to be seen again. This one, we've got the opportunity. It's being advertised and it's being made available.
That's good news. Right. Richard Briggs asks, do you think Tram Train is an opportunity for low-cost railway reopenings, e.g. the DfT restoring your railway fund?
Right. I have a bit of a cynicism with the restoring your railways. It's because a lot of the things they're looking at is actually where do we want railways and low-cost railways. If you want to hear my views of what happened with Beeching, I do a talk on that one, which I believe justifies a lot of what Beeching, or what the Secretary of State for Transport at the time did following the Beeching report. Things have changed, of course, since then, but Tram Train is only really the thing to do is if you're actually going to be running on the street and on the railway, because the vehicles are expensive. However, the principles, particularly the operational principles, are very valid for any reopening or any attempt to introduce lighter weight vehicles onto the main line. I mentioned the Revolution vehicle being developed by the Warwick Manufacturing Group at the University of Warwick, and that vehicle will not have the crashworthiness of a normal heavy rail vehicle. But there again, why don't we do what the Japanese do, which is stop trains hitting each other rather than making them strong enough so when they do hit each other, you can survive it. Stop trains hitting each other is a really good thing. That means you can lightweight your railway a bit more. Strength is then based on other types of issues, and you have a lighter vehicle, which uses less energy. So there's a lot going for the principles and the management of the interface and the management of running lighter weight vehicles on the heavy rail, which I think is where the real benefits from the Tram Train learning will be for reopenings which don't involve street running.
All right. Okay. Thank you very much, Tim. So Carl Gilmore said he's going to be in touch in due course to discuss developments in Cardiff Bay.
Yeah,
and he's had to leave now,
that's
unfortunately. I think as time is
Carl,
getting...
if I just say to Carl, I'm always willing to come down to Cardiff to discuss things when it's safe to do so, or online at other times.
Yeah.
If I do travel down there, as long as you don't pay me, I won't have to charge for the travel.
Right, that sounds good to me. Right, I'm sure.
Yeah, thanks for that, Tim.
Yeah, no, it's all right. I'm very welcome to do that. Being retired now with a railway pension, I'm quite happy to do a lot of stuff pro bono.
Right, so as time is getting on, so I'd like to call upon Brian Bell to propose a vote of thanks.
It's a reflection of the huge disruption to schools this term
a situation it took testing to help to address.
Right. O'Brien?
Andy,
Yep.
it's Andrew Wilson here. Brian Bell has just in the last few minutes had problems with his broadband connection and has unfortunately had to leave. He's probably trying to reconnect at this very time.
Right.
So
Okay.
I will jump in at this point and say to Tim and to Alan Wilkins, who proposed this meeting in the first place, thank you very much indeed for a wonderful opportunity to explore Tram Train, a far more complex proposition than I'd thought when it was initially proposed. And I'm sure that we're all spellbound and have got lots more ideas on how this might come to influence the development of trains, particularly in South Wales. So if I can ask everybody to activate their microphones, and we'll propose a vote of thanks to Tim in the usual manner.
Can't see me.
Right. Okay.
Thank
Thank
you very much for the opportunity, and it's been really enjoyable to be able to talk to you all.
Okay, lovely. Thank you, Tim. Right, so just before we finish, are there any issues arising from the minutes of the last meeting?
Doing and that I think is really important to do.
Oh, I'm not there.
Was
No?
really good for me.
I was
Okay.
earlier. My microphone was up, but where I gone, I no idea.
Oh, never mind. Right. Thank you for offering anyway. So, okay. So then just the next thing. So our next meeting is in January the 11th, which is about track train recording with Kevin Hope. And then our meeting in February. Please note the February meeting was on the 3rd Monday because of a clash with another online meeting. And that will be Alex Hinchelwood and colleagues coming back to talk about the Conwy Valley repairs, really, and work done to make the line more robust for the future. And then March, we have Jeremy Rees coming back to talk about Permanent Way on the Isle of Man. Okay, so
It's working with its advisors.
I'll close the meeting. I wish you all the best for Christmas. If anybody wants to stay on for a quick chat afterwards, I won't be disappearing off immediately. So thank you very much.
Of the previous lockdown.
Yeah, we can stay on a bit as well if people like.
So about the measures to reduce the spread of COVID-19.
Right, okay.
Thank you.
I don't know who's
Has failed to win selection. Seat in the Senate.
Who's got the telly on in the background?
Hello, Tim. I might stay on just for a couple of minutes if that's all right.
How do we get rid of this?
Yeah.
Thank you very much indeed, Tim.
Yeah, that must be.
That's better. Right.
Oh.
So thanks for that, Tim. That was really interesting. So
I was wondering how that's part of that one. How do I stop sharing? It must be here. This one.
yeah, just it's in the settings thing at the top.
Yeah. Is it? Yeah. No, still can't.
Lots of good wishes in the notes as well. So
Yeah.
all right.
Yeah.
You might have found it, Tim.
Can't find the stop share. Oh, there we are. That's that one. Right, there we are. That's better. Sorry about that. Give me Zoom anytime. I understand it.
Right. So it's interesting to note that they're changing their plans a bit in the bay. So
yes, it is. And thank you, Alan, for keeping you up to date. I know you do that on a regular basis in other meetings we go to.
There is a limited amount of information on the Cardiff Council website. It's actually a bit difficult to see the precise detail with what they put on their website, but it certainly seems to incorporate possibly even moving the railway line over into Lloyd George Avenue, which I know
Yeah.
was one. And then using the railway solemn for other development.
Yeah, well, I think that's really the basis of my suggestion. It didn't actually matter which carriageway they put the tramway in.
Well, it's an opportunity of raising some cash, isn't it, to help pay for it all as well, isn't it? It's releasing a bit of land.
Well,
I must admit, when you're talking about the capacity problems as well, I wonder whether perhaps coming round to by Central and avoid the trains going on further south coming through Central might be a future thing to look at as well. So
yeah, the Lord Ben's report referred to that because they were suggesting that some of the additional local trains running along the main line would not be able to use Cardiff Central because of capacity problems and could probably be diverted via Pengam along what is present moment the freight line to the bay. So thank heavens you get it. There's a prospect of getting rid of that quite dreadful terminal platforms at Flourish and putting in what should be there, a full Delta junction to permit full east-west running and connecting going north as well.
that'll be interesting, yeah.
Yeah.
But for the future development, that offers a lot more. It avoids you. Well, yeah, it leaves it open, doesn't it, and flexible.
Yeah.
So there we go. So
yeah, I enjoyed that. That was a great detailed reasoning behind what had been going on. Costs, Tim. The tram train is quite expensive compared even with heavy rail, because it's heavy rail plus it's tramway.
Yeah, compared with heavy rail, it puts a lot of extra cost in to be able to run on the street safely. And compared with just an ordinary tram, it's heavy. It's made heavier internally, and it's got to be big enough and bulky enough to actually be able to put in things like the AWS, TPWS detectors and the like, which can use up a bit of space. Although I think they're a lot smaller than they ever used to be these days. But yes, it does tend to be at the heavier end of trams, and at a sort of 4 to 5 million a vehicle, they're not cheap by any means. And that's why I say if you can just do light rail only, you can do what they do in Tyne and Wear Metro in particular, where they're just redoing the fleet. I don't know what their new vehicles are costing up there, but they don't have to be street legal. They do have the braking capability, because I think the original ones just came with it, but it is a good thing when you've got the lighter vehicles. You have got a chance to stop if you do see an obstruction ahead on the track.
Okay, so that's 4 to 5 million per vehicle per set, effectively.
Per set, yeah, it's a articulated vehicle.
Yeah.
Think of it as an articulated vehicle. I can remember a colleague, Ian Ambrose, who works at Network Rail, but he was on that initial trip, ACORP trip. That's where I first met him. He wasn't working for Network Rail at the time, but he soon joined them. And I've been working with him on this project ever since, and still see him quite often, quite a regular basis, through mainly UK Tram, but occasionally we just get together, have a chat. The heavy rail people saw it as 3 different vehicles, so gave it a unit number and 3 vehicle numbers for the mainline vehicle database, whatever they call it. Whereas he was furious at that because in tramway terms, it is a single vehicle, a single unit, and that's important in the tram world. But they've got over all those problems. It's only semantics in my view. But,
fine.
what I didn't mention, of course, was they had an incident on the opening day where a tram train went into a lorry on the tramway. So it was a tram accident, not a tram train accident. It could have been any of the trams. It was probably lucky in many ways for the people on it. It was a tram train. It had extra buffing, but it did sort of make a considerable amount of damage to the tram train. I was able to view it at their Sheffield depot a few weeks afterwards in the shed they put it in. Got some quite gruesome pictures of the front of it.
Okay, thank you very much indeed.
Yeah, my pleasure.
Thank you for your whole presentation.
Sorry, it's a bit long, but there's a lot to get through in it.
It is, yeah. It's a lot, and it's
Right.
it's been quite interesting. Some of the because all you tend to pick up on is all the bad news when things were running late and this was delayed and it's not going to go up to yeah.
I must admit, the change of administration, i.e. Labour to Tory, didn't help, because the coalition came in. Of course, I had to then do the start again in briefing ministers, but fortunately the minister I had to brief was Norman Baker, who was very keen on trams in general anyway, so he was very keen on it, and that helped keep it going as a project against some of the more senior civil servants' desire to kill it. But we also had the late Stuart Baker as our sponsor, senior sponsor on it, and he was sold fairly early on, so he was keen to keep it going within, and he had a lot more influence in the department than, say, someone like I would have. But so we did manage to keep it going and keep the ministers on board, even if the senior officials weren't. Yes, it's amazing how within the civil service, more junior civil servants can use ministers to keep their projects alive against the wishes of senior civil servants.
Oh well, back to Yes Minister again, yes.
Oh yeah, it's so true, that Yes Minister, having been there, having worked in that organisation. But I must admit, I was glad to get out when I could. Nearly 6 years ago, I had my last day there.
Right. Crikey, that seems to have gone quickly.
Yes, it has actually. The first 2 years dragged a bit, because every time I did a bit of work which was paid, I had to go and ask permission if it was anything to do with railways.
Yeah, well, that's I guess comes with the territory, doesn't it?
That was part of the territory. But once those 2 years was up, I was free to do whatever I wanted, and made life
just
more easy.
So now we haven't managed to turn the recording off for some reason, so it'll stay on until we've actually finished. But I don't think we've said anything that's.
I think. Hold on.
It won't turn off for some reason. So.
Oh no. Well, maybe it's only.
No, they can't turn it off either. So.
Well, as long as they trim it, I don't want my comments about ministers and senior officials to go out more widely.
Yeah. Okay.
Okay.
Lovely. Well, thanks very much indeed again, Tim. So.
My pleasure. And if that gentleman from Transport for Wales needs my email address, you've got it, or I don't know.
Yeah, and I'm sure they'll be in touch. Yeah, so they've got it. They'll have it from the newsletter as well. So so we can get in touch with them. So
Carl Gilmore is the head of infrastructure for Transport for Wales, and is one of the new members that you welcomed in at the start of the meeting.
I know Carl well. Yeah, so yeah.
All right. Okay.
Yeah. So we got his details and that. So
yeah.
So it's good that they're still open-minded to what's going on with that, because it sort of started off as I think they decided they wanted a bit of tramway because that was the fashionable thing to do, and now it's gelling into what really is the benefits of this. Yeah. So.
Yes. Was it? Alan will remind me the name of the person who sort of designed it originally. Mark. Was it Mark? Who originally designed the South Wales Metro?
Mark Barry.
Mark Barry, that's it. Yes.
That's a Mark Barry. Professor of Connectivity, University of South Wales.
Yeah, he's a professor now. Yeah. When I spoke to him about it, he was all very against it, saying we'll need a TWA. But I said you'll need a TWA anyway, or the Welsh equivalent. So why not do it properly? But anyway, we'll see what they think.
Yeah. Well, it's progressing, and obviously there's lots of issues around European funding and all that that's affecting us a bit at the moment. So
yeah, well, we'll have to see. I have to go onto the news and see what's happened today.
well, London's locked down, but that's about it.
Yeah.
There wasn't any news earlier about any other negotiations or anything. So.
That's just, I've got the news site up on my laptop. No.
Right.
Okay then.
Okay,
So,
thank you very much again. So
okay.
thank you to everyone. Have a great Christmas and a happy New Year. It's got to be better than the one we've just gone through, hasn't it?
We can't have a worse year than this last one. I suppose we could do, but if nothing improves. But yeah. All I say, Zoom has kept me sane.
Yes. Yeah.
Okay.
Right. All the best then, guys. Right.
Okay. Good night, everybody.
Cheers. Good night.
Good night.
Right.